Welcome back, guys. So in two of our previous videos, we look at the odd power, how to integrate odd powers of cosine and sine x. So we look at how to integrate odd powers of sine x, and we look at how to integrate odd powers of cosine x, where you use this, and odd powers of sine x, where you use that. So in this video, we're gonna look at non-odd powers of sine and cosine x. So that is when you have even powers and other stuff like that. So this is where it get a little bit harder because we keep memorizing. But I know before you even got into Calc 2, you did trigonometry, and so we're gonna apply a lot of trigonometric functions over here. So let's go on. So with sine, that is sine to the mx, where m is greater than 1 and m is non-odd. So let's say m is even. Right. M is even. So in this case, you're gonna use what is called the double angle formula. The double angle formula, you're gonna use what we usually did in trigonometry. That is sine squared x to be equal to 1 minus cosine 2x divided by 2. That is one of it. And you might also need this one. 2, that's number 2. You also need sine of 2x to be equal to 2 sine x cosine of x. You might also need that guy. So we have two different formulas here, but they are all double angle formulas. And with a cosine, so cosine m, where we have m to be greater than 1 and m is even, we might need this guy here to be equal to 1 plus cosine 2x divided by 2, or we can also use cosine 2x to be equal to cosine squared x minus sine squared x. So we might need that one too. So at least you should be able to remember the first one of both sides, and you should also try to remember the second one too, because you're gonna use that. All right, so let's go ahead. So in this case, we're gonna make an example and try an example which has like both of them in it and see how it goes. So we've been given a problem here to solve. We've been given asked to integrate this guy. Right. So you see directly here that we have an even power or non-odd power of sine. So what we're going to do is we're going to apply our double angle formula. But first, we know this guy can be rewritten as sine squared. Sorry, let me bring this guy here. Sine squared x all squared dx. Then we can say this guy here is equal to just have to like substitute for that. So we have 1 minus cosine 2x divided by 2 all squared dx. So we will then go ahead and we're gonna have this one is also squared, so just 1/4, we can bring it out. And we have 1 minus cosine of 2x squared dx. For now, we can go ahead and open this bracket up. So we're gonna have 1/4. 1 times 1 will give us 1, that is a FOIL. Then we have 1 times that will give us minus cosine 2x, another 1, so we have 2 cosine 2x. Then we're gonna have plus cosine squared of 2x dx. Then in this case we will go ahead and integrate each term. So we're gonna have 1/4. If you do integrate 1, you get x, minus if you do integrate this, you get 2 sine 2x. You use the chain rule, so you divide it by the integral of that. I mean the differential of that of the inside function. So that will be 2. And we're going to do the same for this, but this one we can do it offhand, so we're going to write that. Right. So we know that we've solved this guy. This guy needs to be simplified further. So we can say this guy here can be equal to this one, we cancel that one, sine 2x. Right. But we are left with this guy here, which it's also another thing for us to solve. So we bring it down here. Dx. Now, if you paid attention, you see that it has taken us back to an even power of cosine, which is also greater than 1. So what are we going to do? We're going to apply our double angle formula again. So that one will be equal to, our double angle formula says cosine squared x is equal to 1 plus cosine 2x divided by 2. So we're going to have 1 plus cosine 2x. So we are using this. We are using the 2x right here. We're using the 2x right there to represent the x here, so it's going to give us 4x. 4x divided by 2. Let me bring the integral sign here. Right. So what we're going to do next is we can factor out our our half. We have our dx here, sorry. So we can have 1/2 out. Then we will have 1 plus cosine 4x dx. So if you go ahead, we can integrate this part by part, term by term. So we're going to have 1/2 Then we're gonna have x here. Then we're gonna have plus sine of 4x divided by that is the differential of the inner function. So we're done with that one too. We put all those in pink together. And then we solve the problem. So we started with half here. Let's bring our, we started with quarter here. So let's bring our quarter out. Good. Then we open our bracket here. We have x. Here we have our minus sine 2x. That is the guy right here. Then we have this, which in this case we broke it down into that. So we will have plus 1 over 2 bracket x plus sine 4x divided by 4. So in this case, we have actually solved the problem. But if you are doing definite integrals, you will have to go on to break this guy down and that guy down by using the trigonometry, the second trigonometry functions in order to be able to find those angles. So I'm going to solve more examples on this. So you have to come back later and check. Thank you.